Determine the general solution of the differential equation x squared times y double prime plus xy prime minus y equals x cubed. First, we're going to solve the homogeneous case. So when this thing is equal to 0. So we're going to let y be x to the r, because that's going to be, we're going to assume the solution is going to be of that form. So we have x squared times y double prime. Well, y prime is r times x to the r minus 1. And y double prime is r times r minus 1 to the x times x to the r minus 2. So that's what we're going to put in there. Plus x times y prime. Y prime is r times x to the r minus 1. Minus y, which y is just x to the r. That's going to equal 0. So x squared, x to the r minus 2 is just going to be x to the r times r minus 1. Plus, and then we have, again, x to the r times r minus x to the r equals 0. I can factor in x to the r. I'm left with r times r minus 1 plus r minus 1 equals 0. Then I can factor in r minus 1 and have r plus 1 left over. So if I just like put a parenthesis there, you can see it's just r plus 1. Now x to the r does not equal 0, because x to any power doesn't equal 0. So then we have r minus 1 times r plus 1 equals 0, which means that r is plus or minus 1. So the general solution to the homogeneous equation, we'll call it y sub h for homogeneous, is a constant times times x to the first. Because remember, we assumed y was x to the r. So it's x to the first plus x to the negative first, which is just, c2 over x. Okay. Now we want to find a particular solution using variation of parameters. So for a particular solution, call it y sub p, we know it's going to be some function, we'll call it u sub 1 times x plus u sub 2 divided by x. Basically, you just replace C1 with and C2 with functions. And first we need the Wronskian of the solutions y sub 1 equals x and y sub 2 equals 1 over x. So we have x, 1 over x. The derivative of x is 1. The derivative of 1 over x is negative 1 over x squared. Finding the determinant, we do x times negative 1 over x squared minus 1 times 1 over x. And that's going to give us negative 1 over x minus 1 over x, which is negative 2 over x. Okay, next we use the formulas for u1 prime of x and u2 prime of x. So u1 prime of x is negative y2 of x times g of x over w, the Wronskian, which y2 we said is 1 over x. G of x here is going to equal x cubed over w, the Wronskian, which we said is negative 2 over x. So this is the Wronskian. Simplifying this, we get x cubed over 2. Because the negatives will cancel, x will cancel, and the 1 you don't really need, so it's just x cubed over 2. And then u2 prime of x, that's y1 of x times g of x over the Wronskian. So it's x times x cubed over negative 2 over x. So that's just negative x to the 5th over 2. now we have to integrate these. So u sub 1 of x will just be the integral of u1 prime of x, which is x cubed over 2. And that's just x to the 4th over 8. And then u2 of x is the integral of u2 prime of x, which is negative x to the 5th over 2, which is negative x to the 6th over 12. Therefore, the particular solution, so y sub p, recall was u sub 1 of x, which we just said it's x to the 4th over 8, and then we're going to multiply that by x, plus u2 sub x, which we said is negative x to the 6th over 12, times 1 over x. Simplify that. That's x to the 5th over 8 minus x to the 5th over 12. And they both have x to the 5th. Simplify that to get x to the 5th over 24. So this is our particular solution. And so to get the general solution, y, that we said was the homogeneous solution plus the particular solution. And recall the homogeneous solution was c1x plus c2 over x. And then we're going to add the particular solution, which we said is x to the 5th over 24. And so this is going to be the final answer.